we have a concept that is known as the program HCF, or it is also known as the GCD. Okay, HCF stands for the highest common factor, GCD stands for the greatest common divisor. There is no issue. And we will solve this problem by using math library function. Okay, it is also possible into the Python programming math library functions. So let me check once again. This program is a simple program, that is import math, and I'm just checking the number one value, that is 45, sorry, and number one is just I'm taking the 35, and I'm just want to print such value by using the math library. So math dot HCF, and under this function I just need to pass the num1 comma num2, and let me check this code. Okay, modulo math is no attribute has the HCF and GCD, GCD.
Num2, sir. Num2 you kept as only num.
Okay, just give me 1 second. Yes, this is the one. So in math library, in the Python programming, we use the math library by GCD function. Okay, so there is a function is available into the Python library, that is a GCD. So through this GCD function we can do. And
So
let me
the
check.
same method can't be used for HCF, sir.
No. GCD or HCF are having the same sense. What happened at the time? If you are looking for the GCD, that is the greatest common divisor. So if from this, now what are the factor of the 45? Just let me know. What are the factor of the 45? 5, comma. Okay, first tell me the 3, comma, 5, comma, and
3,
other
5,
9.
9.
3, 5. Now tell me
9,
9.
15.
Okay, and other one is 15. 15.
45.
45 itself. Good. This is a brilliant answer. And what are the factor of this one? So we have the 5 and 7, we can say,
7
and 15 we have
and
also.
35.
First we have
No, sir, 15.
7, 15, 15 and 35. Okay. Now is it clear to all?
No, sir, 15 can't.
So
Can
15 is not a
15 is
factor of
not.
35.
31 is not
Uh,
divisible with 16.
yes, good. So 5, comma 7, comma 35. Okay. Any other factors are of available of these two numbers? 45 or 35. So what is the common thing we have? That is a 5. So that's why the greatest common divisor of such number is 5 we have. So this is a program we can understand by using the GCD function. But instead of putting such function, can we design or can we write a program, or we can say find the GCD of two numbers by using Euclidean method. So here I'm just explaining through the Euclidean method. Okay. So it is very simple concept. So what we need to do? I'm taking the variable that is the result, and in the result store, I'm taking the VSK HCF. This is my function name I'm giving. First value I'm passing one number. Okay, I'm just taking the A, comma B, and here A will be, suppose A will be 68, and B will be, suppose 76. I am taking random value, and after this I need to define the my function, that is VSK HCF. Okay, you can change anything. So here I'm just using A and B. If you want to use XYZ, then you can take, there is no issue. And the including method is saying that you have to use the logic. The loop will continue till Y. So Y means there's a positive value. So loop will always be true. Loop will always be true. And here we need to, like this one, Y comma X, this is Y. So this is a concept which is known as the Euclidean, and under this we need to return X value, and see what is common factor we are getting. So everything is clear to all, and here we need to print the result. So GCD. So what I'm printing, I'm just let me check this code. It will working. It is working or not? Yes, it is working. So find the GCD of two number by using the Euclidean method. This is the Euclidean method. Instead of this Euclidean logic, okay, instead of this Euclidean logic, you can use the LCM method. But what we need to do, you have to put the LCM logic. In this case, you have to use a little bit different logic, and that is known as the smaller value. So, and in that case, you need to find the smallest value rather than the greater value. So that is a little bit logic you are required to update. And how you will do, and that is the most important part. So how you will do, that is the most important part. So you can do. So I'm leaving such exercise to all for finding the answer in appropriate way. So I'm expecting to all the student you can short the problem with the help of the just so this is the next exercise I'm just leaving for important purpose. Now see, finding the GCD of the true number by using just give me 1 second, by using uh, user defined function. So this could be user defined function. Here we are function, but we are using logic of the Euclidean method. Yes, tell me. Yes, who is asking the question?
Sir, me, sir, in that second sentence, sir, while, sir, what is the condition for while
Y means
in that case, sir?
so okay, just so here we are passing the some value that it means in the this function vsk HCF, what we are passing the 68 comma 76, and this value is to be passed over here. So this value belong to the a. So I'm for explaining purpose I can say a is equal to 76 68 and b is equal to 76. Here what we are getting, here we are x is equal to 68
हाँ जी
and v is equal to 76. So you are putting this value over here the while by. So what happened here, we are passing the positive value. So we are passing the positive value, and this loop will start from the initial value, and again this will some value to be updated by. And now keep in mind, this value will be updated by every time. So automatically now first let me start from the very beginning so you can understand. So here I'm passing the only the 76. So here value to be updated first time, that is a x will be by, that is a 76, and y will be updated by the x factor by the y. So if I'm doing the 68 modulo y, and that is to be 0. Okay, so no, this is not so b. We will, what is the value of the 68? 68 modulo by 76. So after doing the modulo, so what value we will get? Yes, please tell me, anyone? Yes, please tell me, anyone. What is the value?
0.
No, 0. Why 0? Because
Mm.
first, no. You are getting again confusing. X, y. So first, what happened? This value to be updated by the x. Okay. So here x will be the 76 modulo. What is the value of the y? That is 76 because it is updated now. So x value is updated, that is 76. Okay. So this is the point. This is the point. And after we are getting something over here, so a by will be able to be updated, and again this will loop cook for the 76 times. Every time we will update the such value, and at the one case we will see the x value to be updated by the minimum value. So we have the GCD, and this is a logic which is done by the Euclidean process. So this is not the Euclidean process. So let me just correct this one. If I'm putting in one instead of the y value, and let us check the what we are getting. So we are getting the error, that is unintended. This is the point, unexpected indentation. So instead of the putting this value, we need to put the y, because we have to do something over here. Okay, just give me 1 second, where we are getting the something. Okay, sorry, this one. Okay, instead of the put one, just let me check this one. Now see, integer divisor is modulo by 0 is not possible. So because there will be the one case where you will get the 0. So that's why we are passing the 76 instead of the 1 or any true value. So if you're putting the true, then at what condition your loop will be terminated. So that's why we are putting the y, and this loop will go for 1 2 or 0 to 76 times. So we are passing the one condition. This is simple logic. Since I was not agree to explain this concept, but this is the simple concept you can find into the anywhere. So this is including method, but a simple method you can use by the LCM. So LCM we have seen, and through the inspired by the LCM program, we can update the SGF. So there is no issue. So this is the main concept. Okay, so we are getting the same answer, and I'm leaving this exercise to all. And this exam you can inspire by the LCM program logic. Okay, so this is the point I'm just leaving for you, and then you can understand, you can solve it.